All right, so in this module, we're going to continue looking at the slopes and constructing the Brouwer diagram, in this case for the intermediate PO2 region. And again, we go on the assumption that we developed in a previous module that the Shockey defects dominate. And so our mass action expression that we developed for Shockeys was that the concentration of the metal vacancies is multiplied by oxygen vacancies. And we also, to further simplify this, came up with the Brouwer approximation for this region because of the Shockey defect, as the concentration of oxygen vacancies is equal to metal vacancies. Okay, and we're going to treat this just like we did the others, where we're going to look to get a expression between the concentration and PO2. The one thing I'll see here is that it's going to be pretty obvious, right? We have concentrations, but we have no factor of PO2, and so we don't expect these to change with PO2. So our result should show that it's constant, the slope is constant. So let's take a look at this. So again, if we want to simplify this, we can use the approximation and plug that in so that we would get something like substituting the metal for what it's equal to, which is oxygen. And so we would really simplify this, and we would have basically this squared. And so if we want to solve, and this is equal to Ks, and so if we want to solve for that, this is going to be equal to the constant, the mass action expression, or equilibrium constant for Shockey, multiplied by 1/2, right? And so this is all we have. We can talk about the, do the log on both sides, but we're going to see there's no factor of PO2 here. So the slope, it should be constant. It should be flat, right? This doesn't change within the intermediate partial pressure region. And because our expression is so simple, we can see that if this is also going to be equal to the metal ion vacancies as well. So both of these lines should be equal to this constant Ks to the 1/2 with no factor. And so they should be constant, and they should be basically on top of each other. The concentrations should be equal in the intermediate region. And so with this in mind, let's head back to the slides and see if that is in fact the case. All right, so we're back here at the Brouwer diagram again, figure 6.6a. This is the one where the Shockey dominates the other reactions in the intermediate region, which is what we're talking about, region 2. So we have the Brouwer approximation down here. And if we look at this region, we see that the dominant species is going to be this line here. And if we look we have to look over to the side, and we see that this is the metal vacancies. That's the line here. But also, you can see that it's looking at the oxygen vacancies as well. Basically, this line, this is flat line, represents both metal vacancies and oxygen vacancies in that intermediate region, which is what we determined, that those concentrations were equal to a constant, so there's no dependence on PO2, and so they're just flat, right? That's what a Shockey defect would mean, is that these concentrations would be flat if they are the dominant species, and that's what we get, and it's equal to Ks to the 1/2, or to the square root, which is also what we saw. So we've just verified the dominant species, these two in the low, these two in the high, and then metal vacancy concentration and oxygen ion vacancy concentration in the intermediate region to be equal to a constant, and therefore no dependence on PO2. In the next module, what we're going to look at is we're going to look at all the other less common or not dominant. So for example, here, and all these others that are less common or minor species in each of those regions. And that's what we'll look at next.